Every major network told viewers the same thing about Hurricane Genevieve this weekend. The storm stays offshore, the track curves away from Mexico, no land threat, nothing that requires attention beyond a passing mention in the weather block. The advisories said the same, every headline said the same. The storm did not read the headlines. At the moment of the most recent advisory, Genevieve sits 500 miles south-southwest of the port of Manzanillo, the single facility that handles 45% of every container arriving in Mexico from the ocean, with maximum sustained winds of 90 miles per hour and life-threatening swells already confirmed on the southwestern coast of Mexico. The disruption is not waiting for landfall. It has begun. By the end of this, you will understand how a storm 500 miles from shore can already be reaching American supply chains, and what the ocean conditions driving Genevieve reveal about the rest of this hurricane season. This is the Science Studio. Let's get into it. Most viewers assume an offshore hurricane does not reach their lives. The satellite loop rolls, the cone bends west, and the story ends at the coastline. It is the correct instinct for most storms in most seasons, and it is wrong for this one. The instinct breaks here. The port of Manzanillo, on the Pacific coast of the Mexican state of Colima, handles 45% of every maritime container shipped into Mexico from the ocean, nearly 4 million TEUs. 20-foot equivalent units, the standard shipping container measurement processed in 2024, funneled through a single berth complex. Before Genevieve formed as an organized system on July 24th, that port was already running 15 to 21-day delays through the first half of 2026. The nearshoring boom, the migration of manufacturing from Asia to Mexico to shorten supply chains into the United States, flooded Manzanillo with container volume. Its infrastructure was not built to absorb. The storm is 500 miles south-southwest of that port right now. It is not approaching. It is already generating confirmed life-threatening swells against Mexico's southwestern coast, on a coastline that feeds directly into Manzanillo's berth approach waters. Port Authority data across prior seasons shows hurricane activity historically adds 5 to 10 days to Manzanillo's berth wait times. That number lands on top of the existing 15 to 21-day baseline. The port moves 4,000 truck movements per day. Every disruption at the berth propagates inland along Federal Highway 200, then northward along the Pan-American corridor. The American terminus of that corridor is where the offshore storm becomes a domestic problem. Goods assembled in Mexican factories from components that entered through Manzanillo do not stay in Mexico. They are trucked across the Laredo, El Paso, and Nogales crossings to American retailers, American automotive plants, and American electronics distributors. A backlog at Manzanillo becomes a backlog in Dallas and Phoenix and Memphis, and that reach starts with what Genevieve has been doing to the water, and to itself since Friday morning. Friday, July 24th, 2026, the GOES-19 geocolor satellite, the primary geostationary weather platform observing the eastern Pacific, captured an organized tropical storm structure for the first time in that basin's ongoing sequence. The system was designated Tropical Storm Genevieve. The center was already exhibiting curved banding at initial detection. Saturday morning arrived with structure. At 9 a.m. Central Standard Time on July 25th, Advisory 5 placed maximum sustained winds at 50 knots, or 58 miles per hour, with a formative central dense overcast, the shield of high, cold cloud tops that indicates a storm's core convection is consolidating, developing over the center. Convection was beginning to wrap. Motion was west-northwest at 13 knots. 6 hours later, the numbers had moved. At 3 p.m. Central Standard Time, Advisory 6 raised intensity to 60 knots, or 69 miles per hour. The advanced Dvorak technique estimate, an automated satellite-based intensity method used by hurricane forecasters, read 65 knots. The Deepern algorithm, a second independent satellite estimator, oscillated between 55 and 60 knots. The central dense overcast was persisting. Banding features were wrapping the western and southern semicircles, and 2 independent rapid intensification models delivered numbers that stop being probabilities and start being consensus. The ship's rapid intensification guidance placed the probability of a 45-knot jump within 36 hours at 74 to 100%. And the DTOPS guidance placed the same event in the 90% range across the same window. The upgrade came before midnight. At 11:09 p.m. Central Standard Time on July 25th, the storm was confirmed at Category 1 hurricane status on the Saffir-Simpson scale. Maximum sustained winds, 80 miles per hour, or 130 kilometers per hour. Minimum central pressure, 993 millibars, or 29.33 inches of mercury. Center position, 500 miles south-southwest of Manzanillo. Forward motion, west-northwest at 15 miles per hour. Tropical storm force winds were already extending outward 125 miles, or 205 kilometers from the center. In the northern outer periphery, south of 16 degrees north latitude, seas measured 8 to 11 feet in southeast to south swell. Sunday morning revised the numbers upward again. At the most recent advisory on the early morning of July 26th, Maximum sustained winds were upgraded to 90 miles per hour, or 150 kilometers per hour. Forward speed increased to 17 miles per hour, still on the west-northwest heading. Life-threatening swells were confirmed already affecting portions of the southwestern coast of Mexico. The storm was still 500 miles from any port. Then the forecast begins. Monday, July the 28th is the forecast Category 4 window. If the models verify, it will be the first Category 4 hurricane in the eastern Pacific since Hurricane Kiko, which peaked at 145 miles per hour on September 3rd, 2025, and again at 140 miles per hour on September 5th, 2025. The HCCA Statistical Dynamical Intensity Model peaks Genevieve at 150 miles per hour. The Google DeepMind Machine Learning Ensemble peaks lower at approximately 100 knots. The National Hurricane Center's forecast sits inside those bounds. Tuesday and Wednesday, July 29th and 30, mark the crossing of the 26 degrees Celsius sea surface temperature isotherm, the temperature threshold below which tropical cyclones cannot sustain themselves. Gradual weakening begins there. And Genevieve is not alone in the basin. Hurricane Fausto, a Category 2, is currently carrying maximum sustained winds of 100 miles per hour, minimum central pressure of 971 millibars, and maximum seas of 34 feet, located 1,060 miles east of Hilo and moving west at 13 miles per hour. 74 to 100% probability of a 45-knot jump in 36 hours is what the guidance says. What it does not say is where that energy is actually coming from, or why this ocean is producing it differently than past years. That answer is not at the water's surface, it is below it. Here is the part of a rapidly intensifying Pacific hurricane that every broadcast report skips, and it is the part that explains why Genevieve is not building the way a normal storm builds. Rapid intensification, the technical term for a jump of 35 miles per hour or more in maximum sustained winds within 24 hours, requires 3 environmental factors to align at the same location and the same time. Genevieve currently has all 3. Sea surface temperatures beneath the storm rate 30 degrees Celsius, 4 degrees above the 26-degree threshold that tropical systems require to sustain deep convection. Vertical wind shear, the change in wind speed and direction with altitude, which under ordinary conditions tears the vertical structure of a hurricane apart, is running near zero across the storm's column. And the deep ocean heat content, which is the third factor, extends well below the surface layer of the water. That third factor is where the story turns. Viewers hear warm water and picture the top of the ocean, the layer a swimmer feels in July, the layer a satellite thermal reading measures. Surface temperature alone does not sustain rapid intensification. A hurricane over shallow warm water churns violently enough to pull cold water up from below through a process called upwelling, and that upwelling cuts the storm's own fuel supply within hours. The storm interrupts itself. Genevieve's ocean has no cold layer available to pull up. The 2026 Eastern Pacific is running an annular warming pattern, a rare configuration in which strong sea surface temperature anomalies encircle the tropical Pacific in a nearly continuous ring across western, northeastern, and southeastern sectors. Unprecedented in the past 40 years of instrument records. That configuration means the warm water beneath Genevieve is not a surface phenomenon. It is a column. The heat runs deep. The everyday analogy is a gas burner. A conventional storm over shallow, warm water is a burner drawing fuel from the top inch of the tank. The moment the burner runs hard, it draws that inch dry and the flame dies back. A storm over deep ocean heat content is a burner with a fuel line that runs the full depth of the tank. The flame does not fade with intensity, it grows with it. Genevieve is burning through the whole tank. And this is the part most people never hear explained. Compact inner cores intensify faster than large ones. Genevieve's inner core, the ring of most violent convection immediately surrounding the eye, is small. A small radius means the storm is spinning tighter around its own axis, building more angular momentum with less rotational friction. In the same way, a figure skater accelerates by pulling arms inward. That is a physics phenomenon, before it is a meteorological one, and it is one of the primary reasons the rapid intensification models are running at 74 to 100% confidence. Compact cores also invite a secondary process, the eye wall replacement cycle, the process in which an outer ring of convection forms, contracts, and overtakes the original inner eye wall, temporarily weakening the storm before potentially rebuilding it stronger, is the mechanism that produced Hurricane Kiko's 2 separate Category 4 peaks in September 2025, with a dip to 115 miles per hour between them. Genevieve's structure is a candidate for the same cycle. If it initiates during the peak intensity window, the storm's forecast track will exhibit an interior oscillation the cone itself will not show. The season-level engine sits above all of this. El Niño, the periodic warming of equatorial Pacific surface water that reduces vertical wind shear across the eastern Pacific and lowers the atmospheric ceiling that normally limits storm development, is the reason 2026's basin has produced 5 named storms already, running approximately 9 days ahead of the historical average pace. The 2026 El Niño is the record warmest at this stage of development in 40 years of observation. NOAA, the National Oceanic and Atmospheric Administration, assigns a 96% probability that it continues through winter 2026 to 27. Every one of the 30 GFDL Spear ensemble members projects a historically unprecedented peak. That is the machine Genevieve is running inside. The 74 to 100% ship's probability figure is not a forecast in the ordinary sense. The scale runs from 0 to 100. A reading of 74 to 100% delivered across 2 independent model systems is not meteorological uncertainty. It is meteorological consensus that the process has either already begun or is effectively certain to begin within hours of the guidance's issuance time. This storm is not just sitting in warm water. It is sitting in warm water that goes all the way down, and that difference is the entire story. The fuel cannot be turned off, and 500 miles up the coast from where that fuel is burning, something else is already starting to give. 45% of every container arriving in Mexico from the ocean passes through one port. That port is Manzanillo, in the state of Colima, on Mexico's Pacific coast, the country's largest container hub and the primary maritime gateway for the nearshoring economy that has redrawn North American manufacturing over the past 4 years. The numbers around it are large. Manzanillo processed nearly 4 million TEUs in 2024. Approximately 4,000 truck movements move through its gates daily. It is the point of entry for the components that arrive by sea, get assembled inland in Mexican factories, and depart northward as finished goods bound for the United States. Before Genevieve formed, the port was already failing to keep up. Berth wait times at Manzanillo were running 15 to 21 days across the first half of 2026, driven not by weather but by structure. A nearshoring-driven volume surge that outpaced the physical infrastructure of the port itself, ships were arriving at a rate the cranes, yards, and inland corridors could not absorb. This was the baseline. This was the number on the day the storm's satellite signature first organized. Genevieve does not need to make landfall at Manzanillo to disrupt it. The mechanism is swell. Life-threatening surf conditions are already confirmed against Mexico's southwestern coast, generated by a storm still 500 miles offshore. Prior season data from the Manzanillo Port Authority shows hurricane activity historically adds 5 to 10 additional days to berth wait times, driven by berth suspension during high swell conditions, tug availability during elevated sea states, and pilotage restrictions in the approach channel. That addition lands on top of a 15 to 21 day existing delay. The combined delay window at Manzanillo from this weekend forward is 20 to 31 days. That is the operational reality at the port that handles 45% of Mexico's maritime container imports before Genevieve reaches its forecast Category 4 peak on Monday. Historical precedent confirms the pattern. The 2020 hurricane that carried the same name, Genevieve, of the prior 6-year retirement rotation, tracked the same basin, remained offshore of any major population center, and never made a direct landfall on a Mexican port. It peaked at Category 4, 130 miles per hour, minimum pressure 950 millibars. It caused $50 million in damage. 6 fatalities were confirmed across Baja California and Southern California. The damage was delivered by swell, rip currents, hurricane-force gusts brushing coastal terrain, and flooding as far north as Southern California. The port disruption arrived without the storm arriving. That is the historical proof point. The disruption did not require contact. The American terminus of the Manzanillo pipeline is the reason this matters outside of Mexico. Finished and semi-finished goods, automotive subassemblies, consumer electronics, appliance components, industrial machinery are trucked from Mexican factory floors to United States border crossings, then onto American retailers, distribution centers, and assembly plants. A backlog at Manzanillo does not stay in Mexico. It arrives weeks later in American warehouse delays, parts shortages, and delivery gaps across sectors that already priced in nearshoring's promised reliability. None of this appears in any current advisory. No mainstream broadcast has connected the storm's position to Manzanillo's operational status. The storm does not need to reach the port. The port is already changing because of the storm. What matters now is the sequence, because the next 72 hours carry specific thresholds, and each one shifts what this event becomes. Friday, July 24th, 2026, is the earliest confirmed moment in Genevieve's instrument record. The GOES 19 geocolor satellite captured the organized tropical storm structure in the eastern Pacific Basin at that timestamp. It was designated Tropical Storm Genevieve on the same date. Every downstream measurement in the storm's history connects backward to that frame. The confirmed sequence walks forward from there. Saturday, July 25th, 9 a.m. Central Standard Time, Advisory 5 placed the storm at 50 knots of maximum sustained wind. The central dense overcast was forming. The ship's guidance flagged rapid intensification as imminent within that same advisory cycle. This is the moment the forecast burden shifted from watching for organization to watching for acceleration. 6 hours moved the numbers meaningfully. Saturday, July 25th, 3 p.m. Central Standard Time, Advisory 6 raised the intensity to 60 knots. The advanced Dvorak technique estimate read 65 knots. Banding features were wrapping the western and southern semicircles of the storm's circulation. The rapid intensification probability was confirmed at 74 to 100% over the following 36 hours. Across both ships' RI variants, one initialized on GFS model output, the other on ECMWF model output. The Category 1 threshold crossed before midnight. Saturday, July 25th, 11:09 p.m. Central Standard Time, Genevieve was confirmed at hurricane status. Winds 80 miles per hour. Central pressure 993 millibars. Center position 500 miles south-southwest of Manzanillo. Motion west-northwest at 15 miles per hour. Tropical storm force wind radius 125 miles from center. Sunday morning raised the number again. Sunday, July 26, early morning advisory. Maximum sustained winds moved to 90 miles per hour. Forward speed accelerated to 17 miles per hour. Life-threatening swells were confirmed already impacting Mexico's southwestern coast. Seas in the outer periphery, south of 16 degrees north, measured 8 to 11 feet in southeast to south swell. Sunday, July 26, ongoing the Manzanillo area and its surrounding coast are under active swell influence. No official watches or warnings have been issued for the port itself. Port operations are not referenced in any advisory issued to date. That is the confirmed record through the morning of this writing. The forecast portion of the timeline begins with the swell propagation window. Sunday night into Monday, July 27th, swells are forecast to reach the southern tip of the Baja California Peninsula. Life-threatening surf and rip current conditions are forecast for that coastline. The Cabo San Lucas approach and its adjacent shipping traffic sit inside that window. Monday, July 28th, is the peak intensity window. Genevieve is forecast to reach Category 4. The HCCA model ceiling is 150 miles per hour. The Google DeepMind machine learning ensemble peaks at approximately 100 knots. The National Hurricane Center's forecast sits between those bounds. If verified, it will be the first Category 4 in the Eastern Pacific since Hurricane Kiko peaked at 145 miles per hour on September 3, 2025. Days 4 and 5, Tuesday and Wednesday, July 29th and 30, mark the weakening phase. The storm's forecast track carries it across the 26 degrees Celsius sea surface temperature isotherm during that window. The rapid intensification cycle concludes. The gradual weakening phase begins. A parallel timeline runs in the same basin at the same time. Hurricane Fausto currently holds Category 2 status. Maximum sustained winds, 100 miles per hour. Minimum central pressure, 971 millibars. Position, 1060 miles east of Hilo, Hawaii. Motion, west at 13 miles per hour. Maximum seas around Fausto's circulation, 34 feet. Fausto is forecast to weaken before reaching Hawaii. Surf impacts from Fausto are expected for eastern-facing Hawaiian shores from Tuesday night into Wednesday. Two simultaneous major Pacific storms, both driven by the same 2026 El Niño engine, are running against forecast desks concurrently. This is not a standard monitoring configuration for a single basin summer. The supply chain timeline runs in parallel to both storms. The swell disruption window for the Manzanillo approach opened this weekend. Historical precedent from prior seasons adds 5 to 10 days to Manzanillo berth weights during hurricane activity. That addition lands on top of the pre-existing 15 to 21-day 2026 baseline. The combined delay window from this point forward is 20 to 31 days at the port that moves 45% of Mexican maritime container imports. U.S.-bound goods already inside the Manzanillo pipeline are inside the affected time frame. Vessels approaching the port this week will hit the disruption. Vessels departing for U.S. destinations during the disruption will arrive at American ports on delayed schedules 3 to 4 weeks from now. Monday is the peak window. But the signals arriving before Monday will tell us whether this storm is tracking inside the models or building towards something the models have not fully resolved. 3 of those signals are already measurable against public data, and they are the ones that separate tracking from guessing. What we now know about Genevieve's intensification rate and its position relative to Manzanillo means that what we watch over the next 72 hours will tell us whether this event stays inside its forecast or becomes something the advisories are not currently describing. Watch the National Hurricane Center advisory intensity figure every 6 hours. If maximum sustained winds breach 115 miles per hour before Monday, the rapid intensification cycle is running hotter than the primary forecast. And that shift moves the Category 4 arrival window forward while expanding the swell disruption radius against the Baja Peninsula and the Manzanillo approach. Watch the Manzanillo Port Authority operational bulletins this week. If published berth wait times reach or exceed 21 days before the end of the week, Genevieve's swells have crossed from forecast disruption into confirmed disruption, and that transition is measurable in real time through publicly available Port Authority publications, updated on a rolling basis. Watch Hurricane Fausto's distance from Hilo as it approaches Hawaii from Tuesday into Wednesday. If Fausto holds Category 2 strength within 800 miles of the eastern Hawaiian shoreline, the surf and rip current threat for Hawaii's eastern beaches escalates beyond the current moderate advisory, and the overlap zone between Fausto's swell field and Genevieve's outer wave energy shifts daily inside a monitoring configuration that is not standard. One misconception should be named and dismissed before it takes root: that a Pacific hurricane which never touches land is not worth monitoring. The 2020 storm that carried the same name caused $50 million in damage and 6 fatalities across Baja California and Southern California without making a direct landfall on any major population center, and the supply chain disruption from the 2026 event has already started, before Genevieve reached its peak intensity. We will be tracking Genevieve's 6-hour intensity advisories through the Category 4 confirmation window on Monday, and the Manzanillo port delay reports as swell impacts move north along the Baja Peninsula through the week.